Surprise! I'm back. Wanted to do a quick addendum maybe, to to the video. I wanted to talk about structure. A lot of you guys are very into structure, into the kind of techie stuff, so I wanted to talk about that. Remember, the keel itself is going to be a dry keel. If the keel gets any water in it, then there's a problem because the keel is being built the same way the hull is being built. So basically you have all the structure that's there, all those frames, even though these are going through the bottom of the hull and into inside the hull. When the plywood is put on, the plywood will go neatly around any penetration. All right, and so then the plywood will be taped, and then it'll be fiberglassed with two. One, two. Uno, dos. Moja mbili. That's Swahili. Two layers of fiberglass. One a heavier, probably 10-ounce fiberglass, and then a lighter 6 or 4-ounce, which will help make it easier to finish the boat. It gives a better finished surface. So if there's any water inside that keel, we'll have a problem. I mean, unless we hit something, eventually you'll see the fillets. And what a fillet is when you take thickened epoxy and you basically use epoxy like you would a weld. So if you see the guy out in Oklahoma building his boat, SB Seeker, you know, he takes plates of metal and he welds them together. Well, that's essentially what we do with thickened epoxy. We use the thickened epoxy to create a seamless bond between two different pieces of material. And so once you put a fillet in, it is almost as strong as a as a doggone weld in a piece of steel. And I mean, really, if you've ever messed with thickened epoxy, I'm telling you, you really should come see what's going to happen here. So we create the fillets with thickened epoxy, and that thing is done. It's sealed. There's no water penetration, especially after we cover it with tape and then with 2 layers of fiberglass and epoxy resin. So please be advised that the keel should be dry. The keel, the centerboard case will also be totally sealed. There'll be one little pipe that runs from the top of the centerboard away above the water line, and so that will not get any water into the hull at all. But that's the only penetration that will be coming from, inside the centerboard trunk that will allow any kind of water anywhere. Let's see what else. Okay, so we talked about that. There have been some questions about those things. The other thing is, in case you're wondering about the strength of this wood here, the strength of Douglas fir under compression is about 6,000 pounds per square inch. Okay, so if you think about this, if you've got a 2x4, a real 2x4, 2 inches by 4 inches, you've got 8 square inches of compressive area. So if you had 8 square inches, right, times 6,000, that's a lot. That's 40 some odd thousand pounds worth of pressure you could theoretically put on a piece of Douglas fir until it would begin to fail. Even if you took the weakest number, which is a shear number. So if you see this beam right here, this beam is not really in compression because the load won't be coming down. It's sort of, diagonal. So if the beam was like this, so if you look at this would be in a shear because the grain of the wood is going against the load. So if the load is coming this way, the grain is against the load. So the compressive nature of wood would be this way in this member. The shear would be against the grain. So if you take the shear value of Douglas fir, it's around 1,600 pounds. So even in shear, 1,600 times, I have, what are those? Those are 1.5 inches by 4. So we're talking about 6 square inches, so 6 square inches times 1,700. You're still talking about 10,000 pounds per each of those. So it's going to be, Lord, 30 of those frames plus those post down beams that are there are crazy. They probably can handle the whole boat by themselves. I mean, 30,000 pounds per beam. So when it's all said and done, the weight of the keel is really designed. The way you typically design something is with a failure factor of about 300%. So if something has a breaking load of 1,000 pounds, you want to make sure you design it to like 3,000 pounds or more. So this keel is definitely beefy enough to carry not only this boat, but a couple of more just like it. So that does it for the addenda to this week's Build a Boat Saturday, the technical component. So if you have any other technical questions, any other engineering questions about what we're doing, let me know. All right? So, for real this time. Well, always peace and blessings, but we'll talk to you later. Peace and blessings.